We've already studied significant figures a little bit. In this video, I'm going to provide you with some additional rules for determining which digits in a number are significant. Now this is probably going to be something new to you, and this will certainly require some practice. But we're going to be using significant figures, or sig figs, all year. So make sure you take the time to kind of study this video well and let things sink in, because once again, we're going to use this quite a bit. Woo, here's all the rules for sig figs. There's a lot of them. All non-zero integers are significant. So that's pretty easy, but when we deal with zeros, that's where it becomes more challenging. We have three types of zeros. We have leading zeros, trap zeros, and then we have trailing zeros. Let's go ahead and look at leading zeros first. Leading zeros are not significant. And as you might have guessed, leading zeros are zeros that lead or that come out in front of a number. So this big number right here has three sig figs. They're the 5, the 6, and the 7. These leading zeros are not significant. Trap zeros, just like it sounds, that's zeros that fall in between significant digits. And trap zeros are significant. Here's three examples. So these would be trap zeros here. These two zeros would be trap zeros. And this here is a trap zero. What type of zeros are these? That's right, these are leading zeros. Leading zeros are not significant, but trapped zeros are. So this number has 1, 2, 3, 4, 5 sig figs. This number has 1, 2, 3, 4, 5 sig figs. And this number has 1, 2, 3, 4, 5 sig figs. Okay, trailing zeros. There's two different kinds. There's trailing zeros with a decimal place, and then trailing zeros without a decimal place. So trailing zeros, as you probably guessed, are zeros that come after a number, like we see here. Trailing zeros in a number with a decimal place are significant. Okay, so does this number here have a decimal place? Yes, it does. It's right there. So will this trailing zero be significant? It will be, because trailing zeros are significant if the number has a decimal place, and this number has a decimal place. What type of zeros are these? That's right, they're leading zeros. Leading zeros are not significant, but trailing zeros in a number with a decimal place are. So this number has 1, 2, 3, 4 sig figs. This number, 1, 2, 3, 4 sig figs. These are all trailing zeros, and this number has a decimal place. What type of zero is this here? Yeah, that's right, this is a trapped zero. And remember that trapped zeros are significant. This is a trailing zero, and trailing zeros are significant if the number has a decimal place, and this number does have a decimal place. So this number has 1, 2, 3, 4 significant figures. Now here we go. Trailing zeros in a whole number may or may not be significant. Use a decimal place to denote zeros that are significant. So sometimes these kind of numbers can be challenging, but once again, this number here, 400, these are trailing zeros. But in this number, there is no decimal place. So these two trailing zeros are not significant. This is also a whole number, and it appears to be the same number, which it is the same number, but this is just precise to the ones place because we have a decimal place here. So once again, look for the decimal place. These trailing zeros are not significant, so this number has 1 sig fig. These trailing zeros are significant because of the decimal place, so this number has 3 sig figs. All right, this probably won't come as a surprise to you, but counting numbers, like 5 people, and defined quantities, or like definitions, like 1,000 milliliters equals 1 liter. I mean, this is the definition of what a liter is. So counting numbers and defined quantities have an infinite number of significant figures. For example, if you counted 5 people in the room, You could put 5.0000000 indefinitely because that's exactly how many people there are. There isn't any room for error. There's no reason for any estimation. It's exactly 5 people. So that would have an infinite number of sig figs. This also has an infinite number of sig figs. And the rules for scientific notation are also very simple. All digits written in scientific notation are significant. Now that's not including this portion here. It's including the digit part that comes out in front. So this has 1, 2, 3, 4 sig figs. This number has 1, 2 sig figs.